Question 1. We are isolating this, which is not on this screen because it's not plugged in. That does not help anybody. Come on. Be smarter than the technology. Alright, that's better. Okay. Isolate the 1/3 x to the 5th by doing what? Come on, yeah, you should be writing this stuff down. This is called homework for a reason, and I'm trying to help you with it. Oh, writing, yes, good. What do we do? How do I get that 1/3 x to the 5th, x over 5, to the x over 5 power to be by itself? Because right now it's being multiplied times 36, so... Oh, divide by 36, excellent choice. So that means that 1/3 over x to the 5th equals... What is 4 divided by 36? Anybody got a fraction for me on that one? Yeah?
1 over 9.
1 over 9. 1 over 9. Now, we don't need a calculator for this particular question. 1 over 3 and 1 over 9 share a common base. What do you think it is?
3.
3! Thank you very much. Nice.
No, but
Oh,
I think
question.
Wouldn't we have to make it, the x would be 10? So it would be 2.
Well, yeah, did you guess and check your way into that one, or did you, what did you do? Oh, yeah, no, I think you got a good strategy there. What I was hoping for was maybe something like this, in case it's not a nice, super nice number. I was hoping that we would transform them into that. Now, but you're right. You're completely right. What can you do with these two exponents? Power of a power rule. What'd you learn about in Algebra 1? Reinforced in Algebra 2. And in pre-calc. Adding exponents is when you're multiplying like bases. We're not multiplying like bases. We're taking the power of a power. So what do? Multiply these two together. That gives me negative x over 5. So we have 3 to the negative x over 5 equals 3 to the negative 2nd. What do you think negative x over 5 equals? Nice. So negative x over 5 equals negative 2. And that does give us the conclusion that x is positive 10. I do appreciate where you headed with that, but I want to make sure everybody, because knows that idea on the concept of the test of doing this kind of thing where you get the same base on both sides. It eluded several of you on that last test as I'm grading it, which I'm still in the process of. So we need a little bit more of this in case you guys and some of you want to retake that first one. Okay. Question 3. We want the 5 to the x over 4 to be by itself. What are you going to do? Divide by 2. Excellent choice. So 5 to the x over 4 equals, if only we knew what 250 divided by 2 was. 125. First I thought you said 425, but then I was like, I think he said 100. I know. At first I was like, why would he go that direction? But then I realized I just misheard. Okay. Next. Is there a common base between 5 and 125?
Yeah.
What is it? 5. Okay, so 5 to the what? 3rd. Okay, so what does that mean about x over 4? What is x over 4? Nobody knows what x over 4 is? 3. And so now we know that x is 12. We want to isolate the 10 on question 5. We want to isolate the 10 to the negative x over 3. How do we isolate that 10 to the negative x over 3? Divide by 2. Okay. So 10 to the negative x over 3. If only we knew what 20 divided by 2 was. Oh, hopefully we got 10. What do we know about negative x over 3? What does negative x over 3 equal? 1. That's right, because right up here, boom, is a 1. Thank you very much.
He just
dropped on it.
That's right. I am the Michael Jordan of short, fat math teachers. That's fat with a PH, by the way. Thank you very much. Okay, but that was a 1 right up there. Hopefully you saw the 1. Yeah, I had to use it. I had to, man. That was good. X equals what? Negative 3. It's so nice when we do this together. Depending on whether people actually write it down or not. You know, that's the other side of things. Some people ignore it.
Does this make you happy?
Yes, I do, when people do their work. And the red ink is a nice touch, too. I like it. All right. Next, it's, as Beyonce would say, a single log. What are we going to do with the single log? Change it to its exponential form. Come on.
It would be 10 with 4 as the
Ooh, nice. Right? Base is 10, exponent is 4. Those of you who are questioning that, remember, logarithm equals exponent. That's why the 4 is your exponent. And I hope we know what 10 to the 4th is, right? 10,000. That whole 1 with 4th is zeros thing. Next. Is that a single log on the left? Yes, it is a single logarithm. So, change it to its other form. What do we got? What's the base? 4. What's the exponent? Negative 1. What's the argument that it equals? X minus 5. Okay, solve. Oh, the 1/4 was good. And then I have to do that. I have them. Now what? What would make it first? That just flip it over. You refuse to combine them together. It's okay. It's okay. What is 4 to the negative first? 1/4. Okay. And now what? Add 5. Okay. So you got the 5 1/4 or 5.25 if you're a decimal fan. It's either one. Doesn't matter to me. If you need practice on those types of questions, 2, 4, 6, 8, 10 are for you. Uh, 11.
So wait, did we get 5, 4, 5, 4?
You just added the 5 on each side, so you got 5 1/4. Is the exponential form isolated? Like in questions 1, 2, and 3, the first thing we had to do was isolate the exponential portion, and you guys did that by dividing. Do we have to do that here? We do not have to divide. So it's ready to be changed into a log. What's the base? 1.06. I didn't say it was a nice base. Now, if you're confused about what goes next, I suggest maybe you find where the exponent should go. Where should the exponent go? Which of the boxes should contain the exponent? The last one, right? So if you know that that's where the exponent should go because log equals exponent, then all you have to do is put the last one in. Now, you're not going to be able to, we couldn't treat 11 like we did some of the other ones where we rewrote both sides to a common base. Nobody in this room knows how to do that. So we needed a different plan. That's why we changed it to a logarithm. But now we got this weird base. And yes, even if you have one of those cheater calculators, you need to use show me the change of base theorem. So what's the change of base theorem say? Log 4.1, the argument, over log of the old base. Okay, now you can use your machine and come up with the weird decimal, right? Log of the argument log of old base. So what did we come up with? What? Man, that's accurate. Sorry, my 4 looks weak. Yep. What's an easy way to double check and see if I'm right? Plugging it back in. So if I type 1.06 to the answer power on my calculator, and it's going to take that nasty long decimal that he just read off, what is it supposed to give me? 4.1. If it doesn't. Now, if suppose I typed in my 24.215, I rounded off what he told me, and I come out with 4.099999763. Is that pretty close to 4.1? Sure it is. I only got that mistake because I rounded off the value, excuse me. Okay, 13. The exponential portion is not isolated. What should I do? Divide by 50. Okay, so e to the 0.035 x. What is 200 divided by 50? 4. And now, folks, we need what I refer to as the degenerate log. Do you know the degenerate log? ln. Yes, thank you very much. That is my joke. You cannot take it. I'm going to try to use it to get on the show. I'm going to try, man. I am definitely going to try, man. Especially because it's base E. It's base E. Isn't that's great?
Yeah.
Okay. What? Oh, yeah? For what? Like a commercial? It's not a coffin. Okay, seriously. Those are for vampires. No, it's not. It's a casket. Seriously. Same thing. That could be my retirement plan right there. Yeah? Oh, really? You think so? Okay. Just watching your math teacher be stupid, that's what. Yeah, okay. All right, so the natural log of what? There's only 2 boxes to fill in here. We already know that the base is E, so not going to write that down. What are the 2 boxes you need to fill in? Where's the exponent go? Where does the exponent go? Yeah, the last one, right? 0.035x. So that means the 4 has to be here. Find me the value of x. Yeah, you'll need them.
What?
You guys get it.
You're gonna do that stuff in your head.
No. It'd take too long for that.
I want you to give me
39.608, you said? Yeah, something like that. Nice job. Any questions on that? Okay. 15. We need that e to the negative x to be by itself. Sorry, I covered up the 2. We want the e to the negative x to be isolated. Maybe I should zoom in. We want that to be by itself. What do we do? Subtract 3. Excellent choice. So 2e to the negative x equals 6 minus 3, which is 3. Now what? Divide by 2. Excellent choice. Couldn't have done it better if you paid me. Oh, wait. I am getting paid. E to the negative x equals... Do you want fractions or decimals? Decimals? Okay. To each his own on that one? So subtract 3, then we divide it by 2. We got the e to the negative x by itself. Okay? What's next? Come on, what's next? You got the exponential part isolated. We're not going to die for him. What do we do? Come on. This should be easy. Put it into the degenerate log form, ln. We need ln. Maybe ln can help us. No. Sometimes it gets on my nerves. Because there's a certain level of arrogance that is hard to swallow sometimes. Okay.
He's a really funny. He has a really funny.
Yeah, I mean, he's got some good points. All right, so natural log of what? 1.5 equals what? Equals negative x, right? The exponent is negative x. Now you got to solve it. Using handy dandy machine. What did we get for x? Negative 0.405, something like that. Okay, any questions on that? Okay. 17. We need a single log. Don't divide by 3 yet. Subtract 4. Thank you. Thank you, thank you. All right. Then divide by 3. All right, so we have the natural log of x minus 3 equals 1/3. Now what? Do not ever say divide by natural log. Oh my goodness, that hurts. Definitely don't do that. Oh man, throw you out of the party.
No.
What? I didn't. Sorry.
I was going to say,
What'd you say?
do you distribute it?
Nope. Okay, there is no distributive property. Okay, so we cannot be doing that. Is this a single log on the left side? Yes or no? It is a single log. Beyonce would say, if it's a single log, we change it to its exponential form. The exponential form. I know, but you like speak under the radar. It's really hard to hear you sometimes. Okay? Yeah. Yeah. You know, things like that. It's like, if I'm not, like really tuned in to the, yeah, I'm like, I don't hear it. You're just quiet. That's all. Okay? There's no distributive property for that function. Because, okay, but that would be kind of like the idea of taking x minus 3 quantity squared and distributing the square, which is what a lot of kids do. So realizing it's x minus 3 times x minus 3, and then they have to FOIL it. That's why they end up missing it when they do that kind of stuff. No, you need to switch to its other form. What's the base? Okay, well, it's already a log, and I can't do anything with it. I need to get rid of this and get it into its other form. So, change it to its other form. What's the base? E. What's the exponent? 1/3. What's the argument that it equals? X minus 3. Set it up like that, and this should go quick. Well, try it, see what you get, and see if you can plug it back in and make it work in the original equation. If it works, that would be awesome. So e to the 1/3. Once you got e to the 1/3 on your calculator, what are you going to do to get x by itself? Add 3. Thank you very much. So we got an approximate value of what? 4.396. Nice. Once you get that single log, you've got to change it to its other form in order to figure out what that is. Okay, now these questions right here, I'm going to let you work on with the graphing calculator. Not today. You can work on that tonight. Okay? But for these kind of questions, I would let you use a machine to come up with those graphs. And once you came up with the graph, then you'd have to identify the domain. I do show you one example in the video tonight that walks you through the algebra, but I think for sake of time, we'll let you graph those and look at the graph to come up with the domain. Okay, now, $25. Is the left side a single log? Is the left side a single log on 25? Yes, it is. So if we've got a single log, change it to exponential form. What's the base? 10. What's the exponent? 6. Remember, log equals exponent. And what's the argument that it equals? X squared. And how are we going to solve that? Take the square root. Thank you very much. When you're in the solving process and you're taking a square root, how many solutions? Ah, yeah, the old plus and minus. So, could be, I guess. Plus and minus what? 10 to the third, folks. That would, remember, this is a 2 out here. 2 goes into 6 3 times. That would be 10 to the third, also known on the street as 1,000. 10 to the third. It was worth a shot. Okay, 27. Yeah, 27 is just about the same thing. Let's skip down to 29. Let's do something. 27's on your list, so check it twice and do it. Okay, but that's you can do that on your own. All right. Let's go down to 29. Definitely want to do 29. Okay, so I'm going to need some space here. Tell me what to do with the 3 and the 4. Multiply them together. Okay, so we'll rewrite this here in a second, but I need to clear this. And oh, no, seriously. And then get some space here to work. Okay, so we got 2 to the x minus 2 to the negative x equals 12, according to what you told me. Multiply the 3 and the 4 together. Okay. 3 times 4 is 12. Oh, okay. We're going to move this to the other side. 2 to the x minus 2 to the negative x Oh, I said move it, and then I didn't. That's pretty bad. What most of you have a hard time realizing at this moment is that that is a quadratic. It's not a normal quadratic, so I do have to preface that. In order to see the quadratic part of this, you have to multiply by 2 to the x all the way through that. Okay? Now, what happens when you multiply those two? You are multiplying like bases. What do you do with the exponents? You said it a little bit ago. When you multiply like bases, you add the exponents. So that's 2. What is x plus x? 2x. When I take 2x and I multiply times the second term, of course it's negative, but when you add those exponents together, what do you get? You get 2 to the 0, which ends up giving you a 1. Does that make sense? That's really the goal. That's why I chose 2 to the x, was because I was trying to get rid of that negative exponent and turn it into something nice.
Do you multiply it to even the 0 on the other side?
Yes, but if you do, and when you do that, it just gives you 0 on that side. Okay, but yes, you do. You multiply all the way through. So 2 to the x times negative 12 is negative 12. Oops, sorry, 2 to the x. Why am I changing that? And then when we do it to the last thing, of course, we get 0. Now, I know at the moment that does not, in your mind, look like a quadratic. So I'm going to rewrite it so that you see the quadratic. I mean, first things first, the constant being in the middle kind of throws you guys off. So we'll put that over here. What you need to realize is that this thing is what we are looking at as x. So the middle term is negative 12 times 2 to the x. Now, how do I look at that first term and realize it's a quadratic or a squared term? Well, there's nothing that says you can't write that as like this. 2 to the x times 2. That's the power of a power property. Plus, you can think of it as commutative property of multiplication. 2 times x, x times 2, it's the same exact thing. Now, why would that be useful? Because the power of a power property allows me to put those parentheses in there, isolating the 2 to the x. Now, why would I do that? So that you could see something. Folks, we have basically in front of us x squared minus 12x minus 1 equals 0. X squared minus 12x minus 1 equals 0. Now, I know that's not exactly what it is, because they have taken the x out and substituted it with 2 to the x. But do you see the pattern? It's the exact same pattern. Something squared minus 12 times something minus 1. That's the same exact pattern that you see right there. I know it looks weird. How are we allowed to solve quadratics? How would you solve that one on the left? Okay, question. So you could say 4 to the x, or you could say 2 to the 2x. It's the same exact thing, because 2 squared is 4. So you could say 4 to the x, or you could say 2 to the 2x. If you do say 4 to the x, then most people don't realize that we're still dealing with a quadratic. So we tried to keep 2 to the 2x, or this part right here, in a form where we could see This is what's replacing x. It's a good question. How do you solve this quadratic in the green box? Any quadratic. If we're not going to factor it, if we're not going to hit it with completing the square, what are you going to do? Plug it into the quadratic formula, aren't you? Okay? We're going to do the quadratic formula, but remember, in the normal quadratic formula, you know how you have the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. What's over on the other side of the equal sign? It's always been an x. But that's what you did in Algebra 1 and Algebra 2. But we're saying that we're replacing this x with 2 to the x. So the quadratic formula is going to look something like that.
So do the 2's get canceled out?
No, you pretty much ignore them. What I want you to do is I want you to realize the coefficients a, b, and c are right here. 1, negative 12, negative 1. It's no different than what you would have done over here. 1, negative 12, negative 1. The quadratic formula isn't changing, folks. The other side of the equal sign changed. So I'm going to do the quadratic formula just like I've always done. What do you know about 2 to the x in terms of a graph? If I asked you to graph y equals 2 to the x, how would you graph that? Just a sketch, basic sketch. What would you say? No, that looks like a log function. Try again. What does an exponential growth function look like? Right? It's the kind of thing you want your money to do, right? Right? So, when does that graph go below the x-axis? When does that graph go below the x-axis? Say it. Never. The range of that function is 0 to infinity. It never goes below the x-axis. Now, I bring that point up to you because you know that in the quadratic formula, you're doing your thing, you're adding, subtracting. Sometimes you get negative numbers. 2 to the x is always bigger than 0. Always. If you get a negative number in the quadratic formula, what are you going to do with that value? Throw it out. That's right, because it doesn't apply. Now, it is also possible that you could get 2 positive numbers and you would have to keep both of them. So, let's see here if I can do this quickly. 12 plus or minus the square root of b squared. Okay, I'll do that in my head. 144 minus 4 times 1 times negative 1. What's minus 4 times 1 times negative 1? Isn't that a plus 4? All over 2 times 1. The discriminant is 148. Can you tell me if you think the square root of 148 is bigger than 12 or smaller than 12? It's bigger than 12, isn't it? Is either one of those numbers, either 12 plus or 12 minus, going to give me a negative number if the square root of 148 is bigger than 12? Aren't we going to have a problem with the negative in this case? So the negative one is going to spit out a bad result. So reach for the calculator, right? 12 plus the square root of 148, which is the only one that will work, divided by 2. Gives me 12.083. Okay, I'm going to erase up here at the top because I want to do this one last answer and be done. So out of that quadratic formula, the only one we got was the 12.083. The other one was a negative number, which we know doesn't work. So if you know that 2 to the x equals 12.083, how do you find x? You got to change it to its log form. That's right. What's the base? 2. The argument 12.083 equals x. How do you solve log base 2 of 12.083? Change the base, exactly, which I'm going to try to squeeze in here. Log of the argument over log of the old base. Wow, that's really crammed in there. Log. Well, I'm typing it out right now. Are you typing it out right now? Okay, all right. I got 3.595. Oh, 595. Sorry, 595. Wow. That is a horrible mess. Wow. Not my best work. I mean, it is and it isn't. If it was a little bit more well organized, it would look better. Whew.